All right, to wrap up with some matrices, first let's see if we're able to identify, this is similar to what we did before, identify if it's in row echelon form or reduced row echelon form or neither. I've given 3 matrices. They are not related to each other. Go ahead and try it out. Pause the video if you would like. I'll come back in a few seconds. All right, so looking at the first matrix over here, we have the leading entry being 1, the next leading entry being a 2. Automatically, this is neither. It is not in row echelon form, which means it's not in reduced row echelon form as well. They have to be a leading coefficient of 1. All right, looking at the second matrix, this is our leading entry. This is our leading entry as well. We don't count 0 as a leading entry. Now, we do have a row of zeros, but it is located at the very bottom. And if I look from top to bottom, my leading entries are going to the right of each other. So this is in reduced echelon form. However, if we want to take a closer look at this, this column with the leading entry 1 has only zeros outside of the leading entry, and this column with the leading entry 1 has only zeros above and below it besides leading entry 1. So this is going to be reduced row echelon form. Keyword is reduced. All right, and then looking at our third matrix over here, we have the leading entry over here, leading entry over here, leading entry over here. So it does have leading entries. We do have a row of 0 at the very bottom, and each of them are moving to the right. So it is reduced echelon, or row echelon form, I'm sorry. Row echelon form. Is it reduced, however? Well, let's take this row, this column right here. This only has zeros below and above it. There's nothing above it, so we don't have to really worry about it. But below it are all zeros, so that's in the clear. If I look at the next column, this has a 0 above the 1 and zeros below the 1. So this is also in the clear. And if I look at this final leading entry column, I don't have to look at a third one because there's no leading entry in that one. But on a third column over here, we have a 4 above the 1. There's a 0 and a 4. 0 is fine. However, because there's a 4, we can only say this is, oops, what is this? Sorry about that. We can only say this is row echelon form. All right. So we're still able to identify, or we're able to identify if it's row echelon form, reduced row echelon form, or neither. Now earlier I showed you how you can put a system into row echelon form, but the question is, how do I go from REF or row echelon to reduced row echelon? How do I go to that? That's something we didn't really talk about as much. Now, I'd recommend every time you're going to reduced row echelon form, you should always try to put it in row echelon form first. Trying to go immediately to reduced row echelon form is not as helpful. But let's work with a row echelon form just so we have the idea. So we're going to have this system. Let's scroll this up. Let's do 1, -2, 4, 3, 0, 1, 2, 7, 0, 0, 1, 2. Now, if you look at the leading entries over here, we have the leading entry 1, 1, and 1. They are all to the right of each other, so that's great. And their leading entries are 1. And there is no row of 0. So this is in row echelon form. It is not in reduced, however. So we have to somehow turn it to reduced. All right. So I know to turn it into reduced row echelon form, each column with the leading entry has to have only the leading entry and 0. So let's look at this column right here. Above this one, there's nothing there, so we don't have to worry about it. Below this one, they're all 0. So we are in the clear for that. That is good to go. Now let's look at the second one over here. Above this one is a -2. I cannot have that. It can only be 0. I have to turn that -2 into a 0. How can I turn this -2 into a 0? Well, using your Gauss elimination or operation on matrices, you can actually turn this to 0 by adding a 2 to it. But how can I get how can I add that first row by 2 without affecting this guy? I don't want to change that 1. Now, if you had said add 2 times row 2 plus row 1, you're going to send to row 1, you are correct. We're going to multiply the second row by 2, and then we're going to add to row 1. It does not change your first entry, your leading entry, because there's a 0 here. 0 times 2 is 0, so I do not change this. This is why I recommend always putting in row echelon before you try to put in reduced row echelon. If you do so, it's actually easier so you can have a bunch of zeros to play with. So if I do so right here, I'm going to have the matrix. I have 1. Now, I'm multiplying the second row by 2, so 1 times 2 is 2. Adding it by -2, that has to be a 0. That was the whole point. If I multiply 2 times 2, that's 4, so this becomes 8. 7 times 2, 14, so that becomes 17. 0, 1, 2, 7. 0, 0, 1, 2. All right, so we're good. Now, let's look at our leading entries again. Boom, boom, boom. This column's good. This column only has zeros now, thankfully above and below, so we're good with that column. The third column, however, I need to fix this guy and this guy. They need to be zeros. So how can I turn them to zeros? Let's first delete the 8. I want to get rid of the 8. Now, some of you guys might have thought of multiplying the second row by -4. If you multiply the second row by -4, you're going to have a value for this entry right here. If you had done so, you would have 1, -4, 8, 17, 0, 1, all that stuff. But the problem is you gain this value. You do not want this value. You want this to remain as a 0. So you cannot multiply the second row by -2 or -4 and then get 0 for the third column. You have to do something else. And the great part about echelon form, these zeros are going to play the role. I want to only affect this value right here and this value. I don't want to affect these first two because these two are good. So what I can do is I can actually multiply or use row 3. Row 3 will only affect the third and fourth entry. It does not affect the first two entries because these two are zeros. So that's the power in echelon form. So what I'm going to do is I'm going to multiply row 3 by -8. Row 3, and I'm going to add it to row 1. And I'm going to send it to row 1 because I want 8 to be a 0. If I do so, I have 1, 0, 0. And then now I got to do some math real quick. -8 times 2, that's -16 plus 17, that is 1. Boom. So I have this matrix after I multiply by -8 to row 3 and add it to row 1, and I'm going to send that to row 1. You got to tell me where you're sending this to. And if you notice, where we're sending it to this time is to row 1 instead of row 3. Earlier, when we simplified, it was the reversed. So you got to make sure you tell me which one are you going to send your values to. All right, now let's see what's good and what's not. Boom, boom, boom. We need to get rid of this 2 right here. This needs to be a 0, so we're going to use the exact same tactic, but instead on row 3, instead of row 1, we're going to change row 2. So we're going to do -2 of row 3 plus row 2. Doing so, that's going to give me 1, 0, 0, 1, 0, 1, 0, and then 4, so that's 3, 0, 0, 1, 2. Boom. And are we done? Let's find out. Boom, boom, boom. Well, now it's in reduced row echelon form. This is because all of these are zeros right here. 0, 0, zeros. All these are zeros in your column, so this is not a good way to actually demonstrate that. Let me just make this better. I should use a different color here. Boom. If I were to look at these columns with the leading entries, besides the leading entries themselves, they are only zeros above and below the leading entry. So this is in reduce row echelon form. Now, reduced row echelon form is very powerful. Very powerful because if I were to ask you for the solution for this system, well, count how many variables there are. How many variables are in this matrix in particular? If you said 4, you were almost close. You were very close. The answer is 3. There are 3 variables. Remember, the last column is your constant. So we're going to use x, y, and z. The last row, if you notice, says z is equal to 2. That's what the last row says. The second to the last row says y is equal to 3. And the first row says x is equal to 1. But did you guys notice something? This was very easy to get the solution. I didn't have to do much mathematics into this after I have my row or reduced row echelon form. The solution is 1, 3, 2. I can see that. That's literally this last column. It works out nicely. So the purpose of reduced row echelon form is that you can easily gather your solutions from that. They are almost clear. The only time it might not be as clear is if you have infinite amount of solutions. However, it is as simplified as possible. And this is why it's unique. This is why reduced row echelon form is unique, because it's pretty much telling you your solutions. And the solution set is unique. You might have infinite solutions, but that set, that collection of solution is unique. So we're able to do that. Now, another powerful thing about reduced row echelon form, because it does show you your answers, your solutions very quickly to the system. But I will let you know that if I tell you to solve a system, you do not have to put it in reduced row echelon form. All you have to do is put it in row echelon form. If you do that, you can still find your solution, because you can still do it. It just requires a bit more math to find your solution at the very end. So what is the reason why we also use reduced row echelon form? Well, for you guys, it's going to be a way to verify if your answer is correct or not, if your solution is right, because we have graphing calculators. So let's talk about the graphing calculator. Let's look at our original matrix, this matrix. If we go to a graphing calculator, a TI-83, so I have this screen and emulator, so that's nice. Boom. Hopefully you guys can see it. What you're going to be going to actually input matrices, this right here says matrices in blue. You might have to zoom in. Let me see. Should I adjust the size? I don't know how to adjust the size, but you guys can adjust it on your screen. If you click second, and then if you click this minus x raised to the negative first power. I think I messed it up. Second, x to the negative first power. That'll take you to that matrix category. There's 3 categories: names, math, and edit. These names represent your matrix. Now, before I even use them, I have to make sure I have the right matrix. So let's go to edit. We're going to edit one of these matrices. Choose any of these letters, any of these names, as long as you remember which is which. I'm going to choose A. Right? Now you need to tell me what size is your matrix. Remember, your size is based off your row and your column. So this right here is 3 rows by 4 columns. This is a 3 by 4. So you're going to type in 3, and then you're going to go over here and type in 4. Automatically, it'll construct a 3 by 4 matrix for you. Now put in your values. 1, enter. Now if you put in negative values, make sure you click the negative sign instead of subtract. It'll mess up. -2, 4. And I encourage you to follow along with this as well. 3, 0, 1, 2, 7. And then the last row is 0, 0, 1, 2. All right? So we have filled our matrix out. Now, I need to leave this screen. You do need to leave this screen. How do you leave this screen? There's a quit button right here. So you're going to go second mode. If you go second mode, you're back at the original screen. Perfect. You need to be in the original screen if you want to do calculations. Now, to actually put this in reduced row echelon form, first, you're going to have to go back to that same application. Yes, you did have to leave, and then you have to go back in. I know that sounds redundant, but now you're going to go back to matrix. And after you're in this category, you're going to go to math. This is going to give you some stuff you can do with your matrix. In particular, you're going to go all the way down, and what we want to do is reduced row echelon form. So if you keep going down, it says reduced row echelon form, right? Oops, I'm going down too much. How do I stop this? Up. RREF, reduced row echelon form. Click enter. And this is why we need to go back to our original screen. This is going to pop up in your original screen. You do not want this to pop up in your matrix, I guess, construction screen. All right, so RREF, if you notice, is an open parentheses. Your calculator treats this as a function. And if you remember what a function is, it needs an input and an output. What do you think I'm going to be throwing inside this function? I'm going to be throwing my matrix inside this function. So now go back to that same, yes, you have to go back continuously. Go back to that same matrix button, x raised to the negative first power, or second x to the negative first power. And now instead of going to edit, you're actually going to click on the name itself. This is your matrix. Do not just type in A. That will not work. You have to put in your matrix by going into the matrix option. So if you click enter now, it'll give you your matrix in reduced row echelon form. So if I scroll all the way down here to my reduced echelon form, they should match up because remember, I stated that they have to be the exact same. Boom. Now your row echelon form might be different, but your reduced row echelon form should be the exact same. And this is a good way just to verify if your solution is correct. Because instantly in reduced row echelon form, I know my x is 1, my y is 3, my z is 2. I can instantly see that just looking at the matrix themselves because we have all these zeros except for our variables. So it's very nice. All right, so remember how to use this in your calculator. It's going to be very helpful for you guys if you guys work on the Chapter 10 test and especially towards the final. So I'd recommend you practice this skill on the Chapter 10 test and all your other assignments beforehand. Okay, so we're able to do that. Great. Now, I'm going to give you guys one so you guys can just try and give it a little exercise, a little practice. So go ahead and try this matrix. See if you could turn this to reduced row echelon form. You should use the calculator as a way of verifying rather than, just inputting for the solution. Otherwise, I can't give you full credit. And I think a lot of you guys have the habit of just putting down a solution and stating your work as shown in the graphing calculator. That is not sufficient. You have to show work for that. It's a good skill to know how to verify your own work. All right, let's work with this matrix. Go ahead, pause the video. See if you can reduce this as much as possible. This is already in echelon form. Already in echelon form. Boom, 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 boom. See if you can put this in reduced row echelon form. I'll come back in a few seconds. Well, if you had tried it, then I'm not going to do all of the operations, but I'm just going to show you several, and then I'm going to put it in the calculator just to make sure that you guys are able to see what the final result is in case you struggle in putting in the calculator and whatnot. So our first column right here, this is already in echelon form, row echelon form, so we're good. But the first column right here, this has a leading entry of 1. Above it, there's nothing here. Below it, they're all 0. So this is already good to go. We're happy about that first column or first leading entry. Boom, this is clear. The second one with the leading entry, above it is a 2. I need to get rid of that guy. I need to get rid of this guy right here. And the way we can get rid of that, it's in the second entry or second column. So I'm going to use the leading entry for the second column. I'm going to use this guy right here, this row. So I'm going to use row 2. I'm going to multiply -2 times row 2. And I'm going to add to row 1. And of course, I'm going to send it to row 1 because I want that to be a 0. So now this is going to turn into 1, 0. Now if I actually did the calculations here, this is -1. 0 times -2, that's 0. So that's -1. And then -10 plus 7, that is -3, 0, 1, -2, 0, 5. And then everything else stayed the exact same. 5, 0, 0, 1. Oops, this is 0, 1, 3. So now if I look at my leading entries, this is a 1, this is a 1, this is a 1, this is a 1. We're almost good. We got to fix up these guys now. Boom. These two values we do need to fix because above the leading entry is a -2 and a -1. So first deal with this guy. Oops, let me use a different color. First deal with this guy, then deal with this guy. I'd recommend doing so. The way you deal with that, if you want to deal with the -1, I'd recommend you use row 3. Using row 3 because you don't want to change this value at all. So you can't use row 2. If you do row 2, you'll change the second column right here. You don't want the second column to be changed. You want it to stay as 0. So I'm going to do, what is that? What is lazy? I could just do row 3 plus row 1 and send it to row 1. So that's not too bad. 1, 0, -1. Oops. Sorry, I got to add them now. 1, 0, 0, 1, 2, 0, 1, -2, 0, 5. And then the third row stays the same. 0, 0, 1, 2, 5. 0, 0, 0, 1, 3. Boom, boom, boom. My leading coefficients or my leading entries. I just need to fix this guy now. That means I'm going to be using the same row, row 3, to fix that because these have zeros. I do not want to affect the other entries before it. So I'm going to do 2 of row 3 plus row 2. Did I say this is right? I should say this is setting to row 2. I apologize. This has to be setting to row 2. Wait, did I do that wrong? This is boom, boom, boom. Did row 3. No, that was right. That was right. That was right. This was right over here, so I apologize. But this right here is row 2. So I'm going to send it to row 2. If I do that, I get 1, 0, 0, 1, 2, 0, 1, 0. And I'm multiplying it by 2. So that's 4. And then 10, 15. Now I have the third row, 0, 0, 1, 2, 5, 0, 0, 0, 1, 3. Boom. So this one's it's a bit large. That's perfectly fine. Then I got to affect this guy, and this guy. You got to keep doing this in order until you get it all done. This should be the last one you need to do, last 3 to change. Once you finish that, then boom. Now, I'm going to skip a couple steps. I'm going to say that we did Gauss elimination. I'm assuming you guys did Gauss elimination or elementary row operations. That's what they call it. But let's suppose we did Gauss elimination. If I go back to my original matrix, let's put this in the calculator just to see if see if you guys can put this in the calculator correctly. Let's go back to our handy dandy graphing calculator, and I had to clear this. Let's see. Let's go to second. Oh my bad. Sorry. Get out of here. Second. X raised to the negative first power, which is matrix. Now instead of A, I'm going to use B. I'm going to edit. I'm going to edit the matrix B. Boom. The size of this matrix, 1, 2, 3, 4. There's 4 rows and 5 columns. So this is a 4 by 5. And the entries are 1, 2, 3, -1, 7, 0, 1, -2, 0, 5, 0, 0, 1, 2, 5, 0, 0, 0, 1, and 3. And now again, once you finish actually inputting these into your matrix, you have to leave this area. So you have to click second mode to quit out of it. It says quit. Now you have to go back into the application again. Boom. And then you're going to instead go to math. And we want to do the reduce row echelon function. So go ahead and go to there. I think I clicked it too many times. Yeah, I did. I was going to do this too many times. 2, 3, 4, boom. And then I'm going to go back into that settings again. And this time I'm going to go under names and put my matrix in. I choose matrix B for this one. Enter. And then your final matrix should be this matrix over here. So go ahead and adjust that. After you did your entire Gauss elimination, I'm not going to show you all that work. I showed you half of it. You're going to have the matrix 1 0 0 0 7 0 1 0 0 3 0 0 1 0 negative 1. And the last row is 0 0 0 1 3. This means my solution, you can do your solution very easily now. So if I want to put this away, if I want to find the solution to this system, there's 4 variables. So I'm going to use W, X, Y, and Z. Eventually, if you get more, you might have to do X1, X2, X3, X4, X sub 5, X sub 6, etc. But right now, I can use different variables because I have enough letters in the alphabet. So if I do this, the last variable, the last row right here says Z, oops, let me use a better one. Z is equal to 3, and this says Y is equal to negative 1. It says X is equal to 3. It says W is equal to 7. It's that easy. So we get 7, 3, negative 1, 3. This is our solution. This is your ordered, there's 4 terms. I guess you call it ordered quartet. Ordered quartet. Instead of an ordered triple or ordered pair, we call it ordered quartet, I believe. I might be wrong. But that is our solution set. All right, it's just a singular point in the 4-dimensional plane. So we're able to do that. Now, these are already in echelon form, going to reduced echelon form. So that might be, nice and everything. But what if I don't give you in, echelon form? What if I just give you a random linear system? So let's just do one last problem. Call it a day. What if I instead give you this system right here? Find solution. Now, if I say find the solution, you do not have to put it in reduced row echelon form. You do have to put it in row echelon form, but you do not need to reduce it all the way. So let's suppose I give you, let's do one with 3 variables. 4x minus 3y minus or plus z equals negative 8, and negative 2x plus y minus 3z equals negative 4, and then x minus y plus 2z equals 3. This system right here. So now that we've worked with matrices, I'm going to expect you guys to do this problem while turning this into a matrix. So the first task is turn to a matrix. I'll give you guys a few seconds. Go ahead and try that out. Come back in a few seconds. All right, if you turn this into a matrix, your matrix should be 4, negative 3, 1, negative 8. That's the first row. The second row is negative 2, 1, negative 3, negative 4. 1, negative 1, 2, and 3. This is your augmented matrix. Remember, when I say augmented matrix, I just mean the last column is your constants. All right, so this is nice. I have my matrix. Now I need to put in row echelon form, which means this guy needs to be a 1. How can I turn that into a 1? Well, if you notice, there's 2 ways to do it. You can either scale this by 1/4, so divide it by 4, or to avoid the fractions, you can swap rows. I'm going to swap row 1, swap with row 3. If I swap those rows, notice this has a 1 right here. I will accomplish my goal much quicker. And this is why you can have different row echelon form matrices, but you will have the same reduced. What if somebody else didn't swap it? What if they just divided by 4? They're going to have fractions in their entries. Now, once that's fully simplified, they should still have the same solution. So that's why the reduce is the exact same. But in general, the row echelon form will not be the same. Boom. So I swapped it. Nice. So this is a 1 for the leading entry. Good. Now the second leading entry also has to be a 1. However, it has to be the right of it. So that means this term right here has to be a 0. That means I have to somehow add it by positive 2. The only way I can add this to positive 2 is by multiply, well, there's multiple ways, but the way I want to do it is I'm going to multiply row 1 by 2 and add it to row 2, send it to row 2. If I do so, I have 1, negative 1, 2, 3, and I have 0, multiplying this by 2, that is negative 1, 4, 1, 2, 6, so that's 2. And then this turns to 4, negative 3, 1, and negative 8. I am not worried about turning it to reduce just yet. First, get it in row echelon form, and then you can decide if you want to reduce it or use your calculator here. I do not mind. So, after you do that, now my leading entry is 1. This is not a 1 though, so I need to turn that to a 1. And I can do that by, well, to turn it into a 1, all I have to do is scale it. So I'm going to multiply this by negative 1 of row 2. If I do so, I have negative 1, or sorry about that. I will have 1, negative 1, 2, 3, 0, 1, negative 1, negative 2, 4, negative 3, 1, negative 8. So this is good to go. This is good to go. Now I need to turn these guys into zeros. All right? Everything to the left of these ones have to be zeros because the 1 has to be to the right. So to do this, I'm going to delete the 4 first. So I'm going to add it by negative 4 of row 1 because I want to affect that. This is the only one that can affect it. Row 1 is the only one. If I try to use row 2, it will not affect that 4. So I'm going to do plus row 4, and I'm going to send it to row 4. If I do that, I'll have 1, negative 1, 2, 3, 0, 1, negative 1, negative 2. This turns into a 0, and negative 4 now, times negative 1, that's positive 4. That's 1. Negative 4 times 2, that's negative 8, plus 1, that's negative 7. Negative 4 times that, that's negative 20. Boom. And let me just make sure everything's good to go. Negative 8, yep. Should be good to go. So now, this is almost there. This is good. This is good. This guy needs to be to the right. So that means I have to turn that to a 0. I have to turn that to a 0. So, to turn it to a 0, I'm going to affect using, I don't want to affect this guy, so I'm going to use row 2. So I'm going to do negative row 1, or row 2, plus row 3. Negative row 2 plus row 3. And I'm going to send that to row 3. I get 1, negative 1, 2, 3, 0, 1, negative 1, negative 2. The third row is the one that changes, turns to 0, 0. And then now I have to do some mental math real quick. 1 plus negative 7, that is negative 6. 1, or negative 2 plus, oh, so that's positive 2, so that's negative 18. I'm almost done. This is good, this is good. This needs to be a 1 to be in echelon form, row echelon form. So I got to scale it by 1 over 6, negative 1 over 6. If I do that, I have 1, negative 1, 2, 3, 0, 1, negative 1, negative 2, 0, 0, 1, 3. Now, you can choose to reduce it. This is in row echelon form. It's not in reduce, but if I ask you to solve the system, you can choose to solve it right here. You do not have to reduce it if you do not want to. So if you wanted to solve it out, the last row represents, so there's 4 columns. There's a 3 by 4, which means there are 3 variables in total. Which means I have exactly x, y, and z as my variables. Let's use those. So that means the last row says z is equal to 3. The second row says y minus z equals negative 2, which is the same thing as saying y minus 3 equals negative 2, which is y is equal to, what is that, 1? And then the first row says x minus y plus 2z equals 3, which is the same thing as x minus 1 plus 2 times 3 equals 3, which what is that going to be, guys? It's going to be x is equal to, I don't want to say for sure. I don't know what it is. Boom, 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 boom. What is that? 6. That's 5. X plus 5 equals 3. So x is equal to negative 2. So that means our solution is negative 2, 1, 3. So you do not need to put it in reduced row echelon form, but if you do not, you might have to do some calculation to solve for x, to solve for y, to solve for z. Reduced row echelon form already solves it out for you. Now, let's just make sure our answer is correct. You can choose to reduce it if you want to by how we did it earlier, but I just want to verify if our solution is correct. So let's go to the original matrix up here. And then this time, I'm going to go into second, x raised to the negative first power. And I'm going to edit. And let's keep A and B, but let's use C now. And C is a 3 by 4 matrix. 3 by 4. And the values are 4, negative 3, 1, negative 8, negative 2, 1, negative 3, negative 4, 1, negative 1, 2, and 3. So we have our matrix. Now we got to get out of this screen. Boom. Second mode. Now I got to go back in the screen. And then I got to click on the function. Let's see, where is that? All the way down here. And you can memorize the codes too. 1, 2, 3, 4, whatever. Maybe some people do that. I don't generally memorize it, but some people do. So now I put in my matrix. Go back into the settings. I'm using matrix C. Enter. Boom. So if you look over here, your x value should be negative 2. Your y value should be 1. And your z value should be 3. And let's just see if that matches up with what we have over here. Boom, 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 boom. Yep. So we have the correct solution. So you do not need to put it in reduced row echelon form, but your calculator does. And that's an easy way to see what your solution is. Now, your calculator can also put it in row echelon form. And let's just see what that looks like. So if I click on second math, oops, not second math, what am I doing? Second, x to the negative first power. Boom. Now, there's a delay on this, unfortunately. I'm going to math, and let's put row echelon form. Not reduced, row echelon form. Let's see if we get the same thing. It might. I actually did not test this. REF, and then let's click on second and put in matrix C. Do you see how it has decimals? Our matrix, where we had it in row echelon form, did not have decimals. And the reason why is because when they did their first step over here, this first step, they didn't swap the rows like we did. They did not. What they chose to do instead, they chose to divide each of this first row by 4, which means this is negative 7.5, which is why you got negative 0.758. Negative 0.75, I apologize. And this is why if you do 1 divided by 4, you get 0.25. So they did that first, and then they used decimals to help solve their system. So whatever helps you out, I'd recommend, hey, just swap the 2 rows. You already see a 1 here. Why deal with decimals when you don't need to? You will get the same solution, but your matrix for row echelon form will be different. Your matrix for your reduced row echelon form will be the exact same. So that covers it for how to use your calculator to help solve these problems. And again, you do have to show work. You can't just show me the final product. That's not going to give you any points. So make sure you show your work. But you're able to put things into reduced row echelon form, given an echelon form. And if you're not, you can put the matrix in echelon form and then put it in reduced row echelon form. And this is how you can solve your system easily. And you know, this general rule is that reduced row echelon form will tell you your solutions right off the bat. The only part that might be tricky is when it has infinite amount of solution. It is still simpler, but you have to be careful because you have to assign the value to be some t value or some s value being all real numbers, just to be sure. All right, well, that ends it for today. I will catch you guys later. Take care. Bye.